Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. Friends, in this session we are going to configure our own custom object detection model which detect object using media pipe, or you can say the TensorFlow Lite on Raspberry Pi 4 with the help of Raspberry Pi 4 camera module. So we will use here Raspberry Pi camera module. Also we will use the latest Raspberry Pi OS bookworm, which is the latest release, and then for training purpose we will use Windows machine because we need label img software. So we will use label img on our Windows machine. We will first create the data using a Raspberry Pi 4 camera module. Okay, we will capture the images. We will send the images using SCP to our Windows machine. Then we will train the images, and then we will send the data to Google Colab machine, and we will create our own TF Lite or Media Pipe Lite model for Raspberry Pi OS. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we will create our own custom object detection model using media pipe, or you can say the TensorFlow Lite. So for that I have created a repository. I will mention the link. Simply copy paste the link inside web browser, and the repository name is rpi4 media pipe tf lite rpicam custom. So go to the code and click on download zip. It will download our zip format repository on Raspberry Pi 4. So same way we will download the repository for Windows machine. So this is what Windows browser. Go to the code, click on download zip, and it will download zip format repository also on our Windows machine because we need SCP software for Windows machine. So I have mentioned setup.exe inside the repository. So let's just first extract our repository with the help of Raspberry Pi. So inside Raspberry Pi we downloaded our repository. So if I open file manager, go to the download, this is what our repository. As you can see, right click on extract here, it will extract our repository. So this is what our repository which we extracted on Raspberry Pi. So same way we will open our file manager on Windows machine, downloads, and this is what the repository which we downloaded on our Windows machine. So right click and then click on extract all. It will extract our repository. So as you can see, this is what our repository. That's it. Now first we will go with the basic setup on Raspberry Pi 4. So let's just say if you completely fresh version install on your Raspberry Pi, so you need to first run some commands. So inside repository I have mentioned imp.txt, which is the text file. So imp.txt, right click simply and open with the text editor, and here just open your terminal, and then we will copy paste these two commands. So first one is basically sudo rm usr. Just copy the command and paste it inside the terminal and hit enter. Because I have already run this command, that's why it said cannot remove. But when you install the latest version of Raspberry Pi bookworm 64-bit version, if you run this command, it will remove the file. Simple. Then we need here upgraded version of Sony Python IDE. So the second command, just copy as it is and mention, or we can say the paste inside the terminal, and then just hit enter. It will upgrade the Sony Python IDE, and then you will have the latest Sony Python IDE. As you can see, it says requirement is already satisfied because I have already updated the Sony Python IDE. Then the NumPy package which we will install after when we have all our process completed, and we will go for final setup, means we will go for final code. So we run all these two basic commands. Simple. So now what we will do first, as I mentioned, first we need our data, means we need our images. So here we will use Raspberry Pi 4 camera module, and we basically detect here Arduino Uno board, and I have here ESP32 board. So this is what the two object which we will detect as a custom object. So for that, inside repository I have created img.py code. With the help of this code you can capture images, but first we need here images folder. So let's just create the images folder inside the repository. Right click, new folder, and images. This is what our folder which we created, and now we will open img.py with the help of Sony Python IDE on our Raspberry Pi 4. Okay, so this is what our Sony Python IDE, and inside that I have opened img.py code, and here let me make a full window of Sony Python IDE basically. So this is the code which capture the images. So maximum frames which I have mentioned 30, you can go with 130. Here you have to simply mention 130. It will capture each class 130 images. Right now for demo purpose 30 images is more than enough for each class. So we will go with the Arduino Uno. So here I have already mentioned the Arduino Uno. So this is the full path, as you can see the images. So here we want to mention our folder path. So if you open the repository, this is what our images folder which we just created. Right click and copy as a path, just select it, copy as a path, and here from these images just go back, means just remove it. Okay, this is the old path, so remove it. Okay, let me mention Control Z, and we don't want to delete double quote, only delete images to home back way. Okay, just delete it. Done, and then press Ctrl+V, because we copy our new folder path, so it will paste the new path of images folder. And this is the image name, because we will first use here Arduino Uno images. So Arduino Uno, which is the image name, and .jpg is the extension. Now just save the code, and now you have to show your Arduino Uno board in front of your Raspberry Pi 4 camera module. Move the Arduino Uno board in different angle, like forward, backward, left, right. You need here a different angle images to create the data set. So now let's just simply run the code. Here one more thing friends, before we run the img.py, we need, of course we need opencv-python, because I have mentioned here a cv2. So go to the tools from Sony Python IDE and manage packages, and here we will search for opencv-python. opencv-python, it will search for opencv-python, first package, click on install button, done. It will install opencv-python. Because I have already installed it, that's why it says uninstall. So this is how for capturing images we need only opencv package. Now we are done, just run the code, and as you can see it's capturing the images of Arduino Uno board, and I am moving the board in front of the camera module in different angle, as you can see. Simple. So this is how you need to capture the images. So now if you open our repository, inside that we created images folder, as you can see there is a 30 images of Arduino Uno board. So this is the 30 images of Arduino Uno board. Now as I mentioned, we need ESP32 board images, so just remove Arduino Uno, no need to remove the %d and all these things. As you can see, only remove the Arduino Uno, which is the class name, and mention here ESP32. So now we will capture ESP32 board 30 images. Let's just save it, and if I run the code, so as you can see this is what our ESP32 board, and again same way, just move the board in different angle for data set for capturing the images. Okay, so we have done. We have both class images inside our repository. Again, if I go inside downloads, where we have our repository and then images, open it, just double click on it, it will open with the help of image viewer, and then we have our all the images. As you can see, this is what ESP32 board. Now as I mentioned, because we need here label IMG software which we have on our Windows machine. So for that we need to move these images folder from Raspberry Pi 4, this images folder inside our downloads repository. We created images, so we need to move this folder on our Windows machine. For that we have here SCP. So SCP is basically the SSH tool. With the help of SSH tool we can simply move the Raspberry Pi folder on Windows machine. So for that we need to first activate the SSH. Let's just say if there is no activate the SSH, simply open terminal. Let me clear the screen. Then run the command sudo space raspi-config, raspi-config. So sudo space raspi-config. This is the command. Hit enter. It will open this kind of window. And here we want to go inside third number option, which is interface option, the third number. So move the down arrow and come to the third number option, hit enter, and then the first option, as you can see, the SSH, just hit enter. And now would you like to SSH server to enable? Yes. So we have to use left and right arrow key, select the yes, hit enter. That's it, the SSH server is enabled. Just hit enter. Okay, again press the tab, come to the finish. That's it, we enable SSH on Raspberry Pi latest operating system bookworm 64-bit version. Done. So now we need our software on Windows machine. So let's just minimize VNC and we will open our repository which we extract on our Windows machine. And friends, here we have our software, which is the WinSCP setup.exe file. Just double click on the setup.exe file, click on it, then you will see this kind of window. Here simply select install for all users. So just select it and click on it. Then here you will see this kind of window, setup our setup file. Click on accept, typical installation, go for next. Then the by default options, click on next, click on install, and it will install WinSCP software. Okay, we have done. Close it, and here we want to go for launch WinSCP. So there is no need to select the open getting started page. So just I will uncheck and click on finish. It will open our WinSCP software, as you can see. So this is what our WinSCP software. So because we enable the SSH on our Raspberry Pi machine, so now we need a Raspberry Pi machine Wi-Fi IP address. So open the VNC server again, and here we will run the command. Let me first clear the screen. We will run the command ifconfig command. It will show all the interface we have. So WLAN and the IP address is 192.168.0.103. Let me clear the screen. Ifconfig is the command. WLAN means the Wi-Fi, and the IP address is 192.168.0.103 in my case. So this is what my host IP, which I want to mention. So minimize, and host name, as I mentioned, 192.168.0.103. Port number by default SSH 22. The username of Raspberry Pi, which is in my case Freed. As you can see, the Freed is basically username. In my case, in your case it may be your name or Pi. So Freed is the my username, which I will mention here in username Freed, and the user password. Okay, so user password, mention it. Done. Now click on login button. It will log in with the Raspberry Pi, means it will open the folder of the Raspberry Pi. Click on accept, and now as you can see, let me minimize the VNC. Okay, so this is the window of our software SCP. This is the window. This side is basically, as you can see, /home/pread. So /home/pread is basically our Raspberry Pi side, and C:users is basically our Windows side. So from Windows side, we want to just click on this back folder option. As you can see, so just click on it, again click on it, and then here you will see all the folders where we have downloads folder. Click on it, downloads, and here we will create a new folder. So click on new directory and create the new folder. Let's just say project. Click on OK. So we created here project folder. So just double click on it, project folder. Now we are inside a project folder in Windows machine. As you can see, the path C users read downloads project, and we are inside the project folder. Now here on Raspberry Pi, our repository, if I open again VNC, our repository is inside /home/pread downloads, and inside downloads we have images folder where we capture our Arduino and ESP32 board images. So we want to copy these images folder to Raspberry Pi to our Windows machine. So for that we need the location. So I got the location, which is download. So I will again minimize VNC, and this is what the downloads folder, as you can see. Then we have RPi4 media pipe, and then we have images. Now just drag and drop. So just drag it and drop it here. As you can see, click on OK. It will paste the images folder from Raspberry Pi to Windows machine. Close it. Click on yes, and now if you open downloads, and I have created here project folder. Inside that we have our images. As you can see, that's it. So we have now our images, and inside that we have all the images which we capture from our Raspberry Pi 4 camera module. Okay, so now we have our images. Now what else we want? Now we want our label.img software. So for label.img we need Python 3.9 version. So just open Microsoft Store. It will open the Microsoft Store. Search for Python 3.9. So just select it Python, and it will open all the Python versions. We have here Python 3.9, which I have already installed. Just click on it, install button, done. It will install Python 3.9 on Windows machine using Microsoft Store. It is really easy, which I have already installed. So I have done with Python 3.9. Now simply open Sony Python IDE. Just open Sony Python IDE, go to the run config interpreter, and here you will see Python executable. Okay, Python executable. Here just drop down the list, because we have now Python 3.9. So we have here setup.exe file. C users read app data, local, Microsoft Windows apps, and Python 3.9 exe. Just select it. Click on OK, and then inside shell you will see the Python version is now changed. We have now Python 3.9.13. So we successfully changed the Python version using Microsoft Store, Python. So go to the again tools, open, first we need to install label.img. So go to the manage packages. Let me show you again here. We have done with Python version. Go to the tools, manage packages, search for label.img. Label.img, hit enter. It will search for label.img, first package, click on install button, done. It will install label.img. It is really easy. Close, go to the tools, open system shell, selected the open system shell. It will open our shell like this way, and here we will run the command label.img. Label.img, hit enter. It will open our label.img. Now we want to select the dir for the images, and we want to select where we want to save our .xml file, which is basically the coordinates of our annotations. So for that, again open file manager and our project folder. Here we have our images. So here we will create Freedom Tech folder. So right click, new folder, and Freedom Tech. Don't change the name. Remember one thing, you have to create a Freedom Tech folder. Freedom Tech, go inside, right click, again we will create here two new folder, which is train and validate. So train train and validate or maybe validation. Okay, if there is a validation, no problem. When we move our folder on our Google Colab, we will rename the folder as per the Google Colab code. Okay, so let's just create here inside Freedom Tech. Let's just create first train and validate folder. Validate. Okay, train and validate. Simple. Now go inside train folder, and here we will create annotations and images folder. So annotations, a capital, annotations, then we will create new folder which is the images, I small, images. So annotations and images folder we created Freedom Tech folder. Inside that we created train and validate folder. Now inside train folder we created annotations, a capital, and the images folder. Now same way inside validate, new, annotations, a capital, annotations, let me rename again, annotations, that's it, annotations. And then again we will create images folder. So this is how inside project folder we have our images which we copy paste from the SCP software. From Raspberry Pi to Windows we have images. Inside that project folder we created Freedom Tech folder. Inside that Freedom Tech folder we created train and validate folder. And then inside validate folder we created annotations, images. Same way inside train folder we created images and annotations. Now open dir, go to the downloads, project folder, and inside images we have images. So just select it, click on select folder, we have all the images. Now where we want to save our XML files for annotations, again go to the change save dir and go to the downloads, project, Freedom Tech, train or validate, anyone you want to select. Go to the validate and go to the annotations. Here inside the annotations we will save .xml. So select folder, done. Now from here you can say we have three options, which is the create ML, Pascal VOC, and YOLO. We need Pascal VOC, so select Pascal VOC, click on create rectangle box and draw the rectangle box on your object. Mention the name which is Arduino Uno, click on OK, save it. And now if you go here in file manager, download, project, Freedom Tech, and I think we go inside validate. Yes, as you can see, validate annotation. This is what the XML file, which is basically this image XML file. So we are successfully saving our annotations. Let me close the window. Now we will go for next image. Again create rectangle box and draw the rectangle box. Click on OK, save it. Next image, create rectangle box, draw the rectangle box and click on OK and click on save. So this is how I will draw the rectangle on Arduino Uno board. When we have our next class, which is ESP32, I will start again video. So friends, now we have our ESP32 board. Same way, Pascal VOC, create rectangle box, draw the rectangle box on it, and we will create the new class which is ESP32. ESP32, click on OK, click on save button, go for next image, click on create rectangle box, then draw the rectangle box on it, and we already select the ESP32, select it, click on OK, click on save, OK, and then go for next image, create rectangle box, draw the rectangle box on it, click on OK, click on save button. So now this is how we will draw the annotations on ESP32 board also. So friends, we completed our annotation process. This is what our last image, 16 out of 16 we have done with Label ING software. So now just close it, close all these things, minimize Sony Python ID, just open our project folder, downloads, project, and freedom check and validate. Inside that we have all the annotations, as you can see, for ESP32 and for Arduino Uno. And inside, now what we want to do, from these annotations, validate annotations, just copy all these annotations, copy it, right click, copy, go back and go to the train folder and go to the train annotation folder, and then just paste it. Paste all these annotations from your validate annotations, just copy it and paste it inside train and annotations. Done. Now we want to copy the images from images folder, copy it, go back, freedom check, go to the train, images, paste it. Okay, then go back, validate, images, paste it. Done. So now we have annotations and images inside both folder. Then now we will create zip format file. So freedom tech, right click and compress to zip file. It will create our freedomtech.zip file. Now we want to upload this file on our Google Drive. So let me open my Google Drive. So friends, I have opened my Google Drive also I have opened our Google Colab. So first we want to upload the freedomtech.zip on Google Drive. So you have to upload the freedomtech.zip on your Google Drive, which you want to use for Google Colab also, means same login, okay, same login with Drive and same login with Google Colab. So now here right click, file upload, go to the downloads, project, freedomtech.zip, click on open it, and it will upload our freedomtech.zip. Meanwhile, open Colab, go to the upload, browse, and then downloads, and then here we have our repository, downloads, we have our repository which is R54, and inside that I have mentioned TF Lite custom. So click on open and it will upload our Colab file on Google Colab. So we uploaded our Colab file and go to the runtime, change runtime type, again Python 3, select T4 GPU, click on save and then click on connect. So we connected successfully. Now we will run our cell one by one. So let's just run first cell. So here friends, when we run our first cell, okay, we completed our first cell, but it says you have to restart the session because we installing here NumPy version, which is our version which we want for TensorFlow. So it will ask you to restart the session. Just click on restart session, it will restart our session. So just click on it. As you can see, it's restarting. Done. And if you scroll down here, as you can see, we successfully install all those packages. This is the last package which we install. Simple. So when you install NumPy, which is the last package, you will see that kind of window which I have shown you, which is the restart session. Just restart your session, it will automatically connect. Now we will import all the modules which we install. Done. Now here we will mount our Google Drive. So as you can see, our freedomtech.zip is successfully uploaded on our Google Drive. Now here we will mount our Google Drive. So let's just run the cell. Of course, we need the permission. So connect to Google Drive. Select your Gmail ID which you use for saving the freedomtech.zip. Click on continue. Scroll down, click on continue, and now it will mount our Google Drive. So we successfully mounted. As you can see, there is a freedomtech.zip file, and let me check here. As you can see, this one, freedomtech.zip. So now the next cell will unzip our freedomtech.zip. So just select it and unzip the freedomtech.zip file. Now let's just scroll down, and here it is. As you can see, validate. So I think we created validate folder. So just click on small folder icon. We have freedomtech folder. Inside that we have train and validate. So we perfectly created validate folder. So we have perfect folder. So now let's just run the next cell. We done. Now let's just run the next cell again. We have done, and then this is the cell where we will start our training using 100 epochs, and this is the dir, means this is the folder where it will save the model. Now let's just run the training code. Okay, so now this cell, it will take some time. So as you can see, it started process. So friends, as you can see, it started training 200. So it will take some time. Meanwhile, I will pause video. So friends, we completed our training session. As you can see, there is a green tick mark, means we completed our training session. 100 out of 100 epochs completed. Now we will run our next cell. So just click on it, it will run the next cell. So we completed our this cell also. Now the last code where we basically have our model, we export the model and it will automatically download base.tflite model into download folder. So let's just run the cell. So we completed our last cell also. As you can see, file is downloaded, and it, as I mentioned, it will automatically download your base.tflite in your download folder. So let's just close the browser. We have done. Now if you open your window machine file manager, as you can see, this is what our base.tflite model which we want to send now on our Raspberry Pi 4. So how do we do? Again, same way, we will open SCP, but first we want to move this model, cut it inside our project folder, just paste it. Now we will again open our WinSCP folder, sorry, not folder, we will open our WinSCP software, and here again we want to mention our Raspberry Pi 4 host name, means the IP address. So 192.168.0.103. Again the username, which is the freed in my case, and then the password, user password, and then click on login and it will log in. Now here on Windows machine, again we will click on the back folder icon. We will go back, and then here we have project folder. As you can see, this is what our project folder, and we have base.tflite, and this is what our Raspberry Pi 4/home/freed. We have our repository inside downloads, and this is what our folder. Just open it and move that base.tflite, just drag and drop inside the Raspberry Pi repository or folder. Now we move it. Now if you close the software, click on no, cancel, Lord, let's just say click on yes, just read it. It is just a closing window, save, and nothing more. Okay, so we close the SCP software. Now we will open our VNC. Okay, VNC connected, and this is what our VNC, and as you can see, this is what our base.tflite which we move from Windows machine to our Raspberry Pi. Now here we will open main.py. So right click, open with the Sony Python IDE. It will open our code, and here it is. As you can see, as I mentioned, we will use the MediaPipe PyCam2. So we already installed OpenCV. Go to the tools, manage packages. This is what our Raspberry Pi. So we will search for MediaPipe package, MediaPipe, and it will search for MediaPipe first package, and click on install button. It will install MediaPipe, which I have already installed it. Then just close it, and we are ready. And here we want to mention our model name, which is the base.tflite. We have done. Now here one more thing, friends, we want to change the NumPy version. So we will open our repository again, and inside that repository we have imp.txt, which is our text file, and then copy pip install NumPy, the version, copy it, open the terminal, and then just paste it here, the command inside terminal, and then hit enter. It will basically change the NumPy version with this version which I have already changed it. Okay, so after installing MediaPipe, run the command pip install NumPy, and it will change the version. Now we are ready, and we will simply run our code. So just click on it, main.py, and it will start our Pi camera. So it started our Pi camera. If I show the Arduino Uno, As you can see, it's detecting the Arduino Uno board. As you can see, it's detecting Arduino Uno. Here it is. As you can see, it's detecting. And then if I show ESP32 board, as you can see, it's detecting ESP32, and this is what basically our Arduino Uno. As you can see, Arduino Uno. So this is how, friends, you can use a media pipe and you can create your own custom object detection model. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.